Hello guys, hello everyone. Welcome to this end-to-end program of AIML where we're gonna learn everything to become a data scientist. So we're gonna learn everything in a scratch manner. So it's gonna be a year-long program. So guys, please make sure that you guys are subscribed to our channel so that we can get the videos whenever it is uploaded. So before coming to the session, make sure that you guys have a proper understanding of whatever we have taught in the previous session, so that you can able to understand what we are gonna speaking here. Okay. So hope you guys are enjoying. We are also enjoying. So let's dive into today's session. Today's session is on supervised learning, and in that we're gonna see clustering. Okay. Hope you guys have understand what is sorry. We have till now we have learned about supervised learning. Today we're gonna see unsupervised learning, inside which we're gonna see the clustering algorithm. Okay. Hope you guys have no doubts related to supervised learning and their kind of algorithms we have seen. If you guys have any doubts related to the supervised learning and the algorithms under it, please like ping us in the comment section so we can take it there and we will solve your doubts. Okay. So today we're gonna see about unsupervised learning algorithm, one of the algorithm called as clustering. Okay. So before going for today's session, let us brush over things like what is meant by unsupervised learning. Okay. So what is meant by unsupervised learning? The model learned by using the unlabeled data. Okay. For example, this is the same example I'm saying in the like two sessions before. Like whenever we are having a consider we are having an apple. Okay. So we're gonna have an apple and then a banana. Okay. What this unsupervised learning model will do means it will just get the apple. Okay. And it will see, okay, it is in red color, so I will keep it in aside in one category. Okay. And it will take the banana, okay, it is in yellow color, I will take it in different category. Okay. It doesn't know the label, but based on the characteristics it is able to classify it to different categories. After categorizing it, we can name them anything that we need. Okay. So whenever the model learns without any label, okay, then it is called as unsupervised learning. Okay. Now you guys are able to brush up the things what we have done in the 4 sessions before. Okay. Now we're gonna see a specific algorithm called as clustering inside the unsupervised learning. So now you guys know clustering is one type of unsupervised learning. Okay. So unsupervised learning is a powerful machine learning technique where algorithm learns patterns and structure from unlabeled data without explicit guidance. Okay. So this is what I'm just explaining. Whenever the machine learns without any guidance, okay, without any labeled data, then it is called as unsupervised learning. Okay. And clustering is a key aspect of unsupervised learning. It aims to group similar data points together based on their inherent characteristics. Okay. So that's a major thing. So based on the features, I'm just saying fruits, right? So based on the color of the fruit, it is able to categorize it. Okay. But it is not able to find the name of it, but it is able to categorize it. Okay. That is called as unsupervised learning, which comes under the classification like category of clustering. Okay. So let's make it simple. Whenever the machine learns using unlabeled data, then it is called as unsupervised learning. That's it. One of the technique in inside it is clustering, where we will cluster the data based on the features. That's it. Okay. So that's from my side. So yes, sir, over to you.
Yes, so unsupervised learning is, guys, where we don't have labeled data and input and output is not already predefined, right? So supervised learning is where we have labeled data and input and output is already defined. Okay. So in supervised learning, so clustering, we are learning clustering. So supervised learning is a powerful machine learning technique where algorithms learn from patterns and structures. So it learns from the patterns. So because there is no labeled data, it will find the hidden patterns and structures from unlabeled data without explicit guidance. Like because input and output is not defined, we just give the data, but still that data is cleaned. Okay, the data is all the statistical analysis, pre-processing, all that is done, guys. Don't think that it is unsupervised learning, whatever garbage you want to give, it will accept. No, you have to do pre-processing, you have to do cleaning, you have to do all the things, you have to choose the right model, you have to do feature engineering and everything. And then the difference is because it won't be defined, you are not using label data, input output is not defined. So That is the only difference. Otherwise, all the pre-processing, everything is done, cleaning and everything. So, clustering is a key aspect of unsupervised learning, which aim is similar data points together. Like the aim is to group similar. Okay, we have to group the similar kind of data points together based on the inherent characteristics. So whatever are the inherent characteristics. Okay, like I'll give example. See, this was done before. Like if you see Darwin or Aristotle, they have they have literally classified in, let's say, animal kingdom. They've not. They will put mammals in one category based on the inherent characteristics. They will put amphibians in different based on their behavior and the characteristics inherent in similarly here we the unsupervised learning aims to group the similar data points together based on the inherent. So the data has inherent natural characteristics, so based on that it will group. Okay, and this is how it will do clustering. Thank you. Let's move to the other session. But guys, remember, watch all these sessions 5 to 10 times. This is we are doing very deep stuff. We are going into deep, like right now we are doing breadth first search, we'll go depth first search. But you will not go into depth if you don't have breadth first search, if you don't understand these concepts. It will go above your head. 5 to 10 times, do reinforced learning, absorb the information, digest the information, and then write in the feedbacks and subscribe to our channel. Press the bell icon so that you get notification, and subscribe to all channels, and also write feedback how we can improve these sessions so that you will get best value out of your time. And thank you so much. Keep learning, be persistent and continuously. Persistence is that is the key for success, guys. Continuously learning, continuous learning skill, develop these skills so you are always relevant. Okay, now OpenAI has launched a new version of chat GPT, guys, which is beyond even PhD thinker. It thinks beyond that. So imagine if you don't have excellence, if you don't learn these concepts, so you won't be relevant. So be always continuously learn these fundamental concepts so that you will build the knowledge structure on it, and then you will become specialized into data science in AIML, deep learning. So continuous learning with persistence and patience. Keep learning. Thank you.
Yeah, sure. So adding on to Sir's point, guys, like we are learning a field, right? Data science. So be on track of it. Sir has just told now, OpenAI has launched a new model, right? Yeah, that's very boom today. Okay, so just have a like a current affairs that we are having related to this data science field. Okay, so yeah, we can move on to the next slide. So yeah. So now, what is clustering? Okay, clustering is a task of partitioning a data into groups or clusters where data points within a clusters are more similar to each other than those in other clusters. Okay, I will put it in the simple manner. Okay, we are having apple and we are having banana. Okay, whenever we the model sees it is a red color, it is gonna throw it to a category A. Consider it is gonna throw it to a category A. So it is gonna have the same set of data points, that is only apple, because they are all in the red color. Whereas if it is gonna see the banana, it is in yellow color, so it will throw into the some other category which is called as B. Okay, now the category A, which has the similar properties, all the data in the category A will have the similar properties and it differ from the category B, but the data points in the category B will have all have the same characteristics. Okay, this is what the clustering means. Okay, so first thing, in the clustering we are having data exploration. So clustering helps uncover hidden patterns and relationship within data, retrieving underlying structures that may not be immediate apparent. Okay, the thing is, if you go for a clustering, you can identify the data points, how it is distributed based on the categories. Okay, if we go for a line plot or distribution plot, we can find how a data is distributed, but like how data are grouped, like that we can do by using the clustering. Next is customer segmentation. Actually, this is what the I will say it is a basic example for the clustering. Okay, identify distinct customer based on their purchase behavior, preference, and demography, enabling target marketing campaign. This is a great example for clustering. Consider, I will say this clustering, the customer segmentation, okay, in a simple manner. So whenever we consider, there are different customers who gonna purchase something, okay, we can classify them, right, based on the salary and what they are purchasing, okay. The person is having a low salary and he is buying a low amount of products. Low salary but high amount of product the person is buying. Like that, there is a two category. Then high salary, the person is buying low amount of product. High salary, the person is buying high amount of product. Like that, we can create a cluster kind of thing. That is what the customer segmentation, I'm telling in a layman manner. So next is anomaly detection. Identify outliers or unusual data points that deviate significantly from the rest of the data, helping to detect anomaly and potential errors. Yeah, right. We have already discussing about an example, right? Whenever it is in the red color, it's gonna throw it to the category of A, that is apple. Whereas if it is a yellow color, it's gonna throw it to the category called as B, which is called as a banana. Okay. Consider we are getting something like in a green color. Okay. Consider we are having a dry mango. Okay. That is also yellow. Okay. We will consider some other like green color. Okay. Some kind of vegetables like. So let us have something called as a carrot. Okay. Carrot is something like a orange color, right? It doesn't belongs to both the category A and category B. So it will be like a different category C. Now, if you look at the data set, most of the data are in the A and B, but there is only one data belongs to C, that is called as a carrot. So now the carrot is the outlier. So this kind of clustering algorithm makes us easily to detect the anomaly. Okay? I hope you guys are understanding. Okay? Next is image segmentation. Segmenting image into different regions based on color, texture, or other features used in object recognition and image analysis. Guys, this image segmentation is also like a great example and great real world example for this clustering, because like consider if you are seeing an image, okay, so you just consider this is a frame, I'm just talking, right? So consider this is an image. If you guys need to cluster this, how you can cluster? Background, okay, that is one cluster, and this is a human, this is another cluster, right? So in this way, it is helpful in image segmentation also. I'm saying in a scratch manner. There are different applications out there, like OCR is one of the application in image segmentation, where we will be using clustering in order to detect the boundary box. So guys, don't worry about the thing, like whatever the technical terms that we are speaking, don't worry about it. Just understand the theoretical concept, because like we are just doing the breadth first search. We are gonna do depth first search, so then we're gonna have a proper understanding of what this technology is. Okay, so now keep it in mind. Image segmentation is also comes under the category of this cluster. Okay, so that's from my side. Yes, sir. Over to you.
Yes. So what is clustering, guys? Clustering is we make clusters. In a simple definition, if you understand what is clustering, is we make different groups. That is what is called cluster. We make different clusters, different groups, different segments, okay? So that we can deeply understand about that particular data set. Okay, here clustering is a task pertaining to data set into groups. That's what I said. Groups or clusters, you can say that, where data points within the cluster are more similar. Like they would not be exactly similar. If they are similar, if A is similar to B, then neither, yeah, either A will be there or B will be there. Why we need to keep A and B? So there would be little similarity. Okay, that is what you have to understand. That's why being similar, we put them into a cluster. Okay, so those, what are the criteria? So data exploration, clustering helps to the clustering which we make groups and different clusters, it helps us to uncover hidden patterns, relationship between data, revealing underlying structures that may not be immediately apparent. Okay, and then customer segmentation identifies distinct customer group based on their purchasing behavior, huh? Preferences, demographic, enabling target market campaign. So because you need to have niche market, right? Niche market is very, so you can't, if you are selling Mercedes, you can't sell it to somebody who is having 50,000 salary per month, right? Or 20,000 salary. You need to find that specific niche, that how much should be minimum income for somebody to buy this kind of. So what would be your target audience? Suppose you are working in Mercedes company and you are a data scientist and you have to do this work, though they already have a lot of data, but suppose you want to do it from scratch. So you have to define your customer segment, and lot of behaviors, lot of segmentation and targeting the right market for their behaviors. You have to understand everything, and then you have to design your marketing campaign, policies, strategies, and you don't want to spend your time, resources on something like thousands of people who are not going to buy your product. So you have to focus on only people who are going to buy your product, and they have those data, they fall in that data baseline, okay, that bracket, so the target market, okay, then and only. So anomaly detection, it helps to identify outliers, okay. So outliers for a merge trees, outlier would be like somebody who's earning 10,000 rupees and you're selling merch to that person. You will never buy till the time his salary or his lifestyle, and not only salary but his lifestyle. So the other thing. So uh, and sometimes, like, your product is only designed for 20. Suppose people are like a motorcycle, so people they can afford like 20-30,000 income, people can afford motorcycle. So now what you do is, outlier for that market would be you trying to sell motorcycle, somebody who is driving a BMW motorcycle, or which is at 5 lakh or 10 lakh. So that way, outlier depends on your baseline. What is your baseline? So it will be always dynamic. What is your problem statement? What are the characteristics of your data? So it depends on your baseline, guys, so you understand that. So outlier here might not be outlier there, or outlier there might not be outlier here. So it is very dynamic. So don't fix a constant definition to outlier, okay. Outlier, it is based on your baseline. What is your baseline? That is what you have to understand. And then identifying outlier, unusual data points that deviate significant from the rest of the data, which is your baseline, okay, helping to direct anomalies and potential errors. It helps us. Anomaly detection, outliers are also anomalies, okay. So they are the errors for our baseline. That's what. They are not falling in the mean area, normal distribution area, okay. That mountain, curvy mountain, you have positive and negative. They are not falling there. They are away from that. That is why they are called outliers. So then we have image segmentation. Clustering also helps us. Images differentiates region based on color, text, based on pixels, guys, okay. The computer doesn't know. Computer knows only binary, which is like RBG. We based on that, so it will do permutation combination. It will see how much color is there, how many pixels are there, and whatever you do the training, and as per that, your model will be built and you will have output. So based on the color, text, and features used in the object, that also matters, okay. The graphics of it, recognition recognizes the image analysis also. So this is how we do clustering, so that we have classified data. Classified means it has segments, okay. So if you have seen a medical shop, if you have gone to Apollo medical shop, you'll see they have done clustering in their medicines. Like every medicine would be tagged, and there would be clustering between emergency medicine. For children, it would be separate section, segment. They have done the clustering. Physical level, you can do this. And then you can see in post office also, they do clustering. They keep the speed post separate, the other one separate, the big boxes separate. There are different criterias for measurement, and they will see height and weight of the box and stuff. So ultimately, whatever models you are going to make, you are going to make it for a physical and real life, real world, right? So you need to understand from a real life point of view that how I'm going to use clustering in real life. So try to organize even your house through clustering. You can keep your books, even library, you have different sections, right? You have business section separate, mathematics separate, fiction separate. Clustering, I can see everywhere clustering if you observe. So you can get ideas from the real world. The patterns are in the real world. So let us move to the other section. Deeply understand these concepts. They are very powerful, guys.
Yeah, sure, sir. So let's move on to the next thing. Okay, now we're gonna see different types in the cluster. Okay, clustering is a type of unsupervised learning. Under unsupervised learning, we are having clustering. Clustering gonna have different types. Okay, first we're gonna see k-means clustering. Okay, I think this is a popular clustering technique that we are having. K-means is a popular and simple clustering technique that aims to partition the data into k centers where k is the predetermined numbers. Okay, so I will put it in a simple manner. Okay, whenever we are having a data points, okay, right, we will just find the centroid. Okay, we will just find the centroid. Consider in this also we are having this much data, right? Just consider we are going to have a centroid. This is one centroid, this is another, this is another, this is one, this is one. So we will have a radius. So the data points which are inside this is belong to this cluster, inside this is belongs to this cluster, and inside this belongs to this cluster, and inside this belongs to this cluster. That means we need to find the centroid, that is a center value, and then we need to form a circle based on the radius, and whatever the data points comes inside that circle belongs to the centroid, that cluster. Okay, like that we will form the cluster. So let us see the simple explanation, steps. Let us see. First is initialization. The algorithm starts by randomly selecting k initial clusters which represent the center of each clusters. Okay, so it starts with finding the centroid, guys. Okay, it will start, first of all it will find initial centroid, that is called as k value. Okay, then assign assignment. Okay, each data point is assigned to the cluster whose centroid is closer to it. Okay, that is the same thing, right? We need to find the cluster first, and whatever the data points are closer to the cluster, we will just move it to that cluster. Okay, then update. The centroids are recalculated as the mean of all data points assigned to each cluster. That's it. Okay, then we need to keep on updating this centroid so that the centroid moves, and then finally it will come to the point where all the data points belong to that cluster, single cluster, by using that centroid. Finally, we need to go for iteration. Step 2 and 3 are represented until the centroids no longer changes significantly, indicating convergence. Okay, I will put it in simple manner. We are having the data points. From the data points, we need to find the centroid. Whatever the data points which are closer to the centroid, we need to make it as a cluster until, and we need to keep on doing this until it converges. Okay, that's it. That is what the K means clustering. Okay, yes, sir. Over to you.
Yes, guys. So K-means clustering is that uh, popular and simple clustering. It is a very popular and simple clustering technique. So uh, it is the algorithm which aims to predict data points into K clusters. Okay, where K is a predetermined number. It is already predetermined, so you don't need to worry about what is K. Sometimes these terms, like, you will feel like uh, I never heard what is K, right? So it is a predetermined number. So you don't worry about that. Just remember this. So initialization is first point. The algorithm starts by random selection K. K is a random selection, initial centroid, which represents the center of the each cluster. So you understand K is a it is randomly selected. It is a random. It represents center of the each cluster. You just imagine that K is a center for each cluster. It represents the particulars. Okay, so that's what is called centroid. Centroid is the word centroid comes from center. Okay, so this is what is called centroids. So second is you can see here the the which one is, can you write in the comment section which one is centroid in this picture? So which one? So the centroid here, yeah, centroid is this particular. So this, yeah, uh, the red one is the centroid. You can see the other, there are other centroids also. Like K means clustering, you will have different that centroids. So it's not centroid, it is centroids. So you have different centroids. Okay. So each data point is assigned to a cluster whose centroid is closest to it. So there you'll see, if you have seen army installments, guys, you'll see they apply these things, these algorithms. Like they will have small units, and then there would be a big unit which would be governing, and they will have small clusters, right? And then there would be major or um, other officers, and then you have a then you have higher hierarchy brigadier who is managing the entire that particular uh, big unit, which has small clusters. So you can see clustering, I think, in hospitals also. You have big medical college, then you have small primary hospitals. They can be called as clusters. Like to relate it with real life, you can see other examples also. So you would have seen when there is election and polling, they create clusters. Okay, the polling booths are related to this particular cluster. They belong to this cluster. This belongs to this north, south, east, west. In the particular district, or in particular state, will have different level of. So there are different hierarchies. You can relate it. So this is how the each data point is assigned to a cluster whose center is close to it. So that there's a decentralization. With this we see decentralized, and then we try to understand data in a better manner. That is why clustering is done. Okay, specifically based on similarities. Then update the centroids are then uh, re recirculated as the mean of the data point assigned to each cluster. So again, they are recirculated uh, as the mean of the data point assigned to each cluster. So there is this is the third term, which says that the centroids are then recirculated as the mean of data point assigned to each cluster. So this will help us in terms of these things help us to understand data properly, and then we measure the distance between the closest data point and all. Then iterations, step 2 and 3 repeat until centroid no longer changes significant in indicating convergence. So it is repeating, it's like kind of a loop till the time it reaches to its significant conversion, right? It reaches to a significant point. It will be iteration will be done till the objective is achieved through k-means clustering. So let's move to the other slide. Thanks.
Yeah, guys. So that's the thing. That's all about this K-means clustering. This is one of the technique. Okay, let's move on to the next one. Okay, let's see what we are having. Hierarchical clustering. So hierarchical clustering is also considered. It is also a popular technique, but not that much as a K-means. But like consider hierarchical clustering is also as a big clustering technique, right? I think from the word you can able to understand, right? Hierarchy is kind of a, like, consider it's a tree like structure, okay? Hierarchical clustering builds a hierarchy of cluster by initiating, so from merging or splitting the clusters based on their similarities or dissimilarities, okay? Within hierarchical clustering we are having different techniques. First is agglomerative clustering. It starts with each data points as its own cluster, and it iterates, merging the two closest cluster until it becomes a single remaining cluster. Agglomerative, okay. Consider, uh, I will put it in a simple manner, okay. We are having apple, mango, banana, orange. Those are separate clusters. First, we gonna merge two things, okay. Like, consider we are having apple, mango, banana, and orange. Okay, mango and banana are in yellow color. Okay, we will cluster that. First of all, we will cluster that, and these things are separate, right? The apple and orange. Okay, then now we need to cluster four of them, because already we have clustered these two things based on the concept of yellow color, the mango and then banana. Yellow color we have clustered, and other things are red and orange, so we're not able to cluster. Now we need to cluster all the four. How we can cluster? All our fruits, right? We can cluster in that manner. That is what the agglomeratic clustering. From the, what to say, from the single cluster it makes up the huge cluster. That is what agglomeratic clustering. I hope this concept is very easy to understand by using this example. Next, we are having diversity clustering. Starts with all data points in a single cluster and iteratively splitting the clusters into two subclusters until each data points is into its own clusters. Okay, yeah, I put it in the same manner. We are having fruits. Okay, we are having orange, apple, mango, and banana. Okay. How we can split it? First of all, okay, we can split it based on color, right? How we can split it based on color? So yellow, and then we from the yellow we are having mango and banana, and red is apple, and then we are having something called as orange, in orange color. Okay, now these two are in a same cluster, like based on the yellow color. Now based on the food, we gonna throw it in different or shape, okay, because like mango is in different shape, and then banana is different shape. Further we will split it. Okay, now we are having finally apple in one cluster, banana in one cluster, mango in one cluster, and then orange in one cluster. Finally what happens? A huge bucket, it's split into smaller buckets, okay, with their own elements. Okay, that's it. So I will say, I will put it in a simple manner, guys. Agglomerated clustering is bottom-up approach, right? We are having single cluster to the, multiple cluster to a single cluster. Whereas diverse clustering is the top-down approach, where we will be having a one cluster to multiple clusters. Okay, I have done it in a simple manner. Okay, and then we are having dendrogram. The result of the hierarchical clustering are often visualized as a dendrograms, which shows the hierarchy relationship between clusters. Okay, I'm just explaining a tree-like structure called as. I'm just explaining a tree-like structure called dendrogram. Hierarchical clustering is represented by using a dendrogram, top down or bottom up. That's it. Okay. I hope this is very easier for you when compared to the k means. But like k means is like, consider a concept. Whenever you think of k means, there is a centroid and we need to create a cluster. When it comes to hierarchical clustering, you need to consider it is a tree-like structure. Okay, there is a dendrogram. It will be a top-down or bottom-up approach. That's it. Okay. So that's from my side. Yes, sir. Over to you.
Yeah. Hierarchical clustering is again the word hierarchy. It comes from hierarchy. So whenever you are learning any concept, understand the fundamental concept of that particular word. Go and know the nomenclature of that particular etymology, what we say. Go to the you and try to absorb that. Hierarchical clustering comes from hierarchy. So there is a hierarchy in clustering. Huh? Now you'll see that. So hierarchical clustering builds a hierarchy of clusters by it iteratively uh, merging or splitting clusters based on similar or dissimilarity. So that's a what? Either it would be similar or it would be dissimilar. Agglomerative clustering is starts with each data as its own cluster, iteratively merges into two closest clusters until single cluster remains. So this is how agglomerative clustering works. Then we have divisive clustering, which is starts with all data points uh,
Yeah,
in a single
so yeah.
in a single in a single cluster, iteratively splits the cluster into two sub clusters until data point and it's in its own cluster. Okay, so the difference here is the it starts with the data points in a single cluster and iteratively splits clusters into two sub clusters. That is the decisive clustering.
Yeah, so we are just talking about cluster. Yeah.
Yeah.
So yeah, like yeah, agglomeratic clustering.
So so
Like Cyrus, yeah,
Then we have dendrogram, which is like result of a hierarchical clustering, are often visualized as a dendrograms, which shows the hierarchical relation between clusters. So this is how hierarchical clustering works: agglomerative clustering, decisive clustering, dendrogram clustering. So they have different significance and characteristics. So we use these clustering for data, and we understand, and it works differently in the algorithm. But here we need to understand concepts clearly. So what is the significance, limits and demerits, merits and demerits of particular algorithm and particular technique, so that we can use them properly when we go for application. Thank you so much. Let's move to the other slide.
yeah, sure. So guys, I think you guys have understand, right? Whenever it is a centroid, it comes under the k-means. Okay. Whenever it comes under top down or bottom up approach, it comes under the hierarchical cluster. Okay. So we will pass here. Okay. We're gonna see lots of algorithm in this unsupervised learning that is basically within clustering. So yeah, this is all about today. Hope you guys have enjoyed this session. So we will all meet in the next session. So before that, if you guys have any doubts, please ping in the comments. We are here to help you. Bye, guys. Take care. We will meet in the next session. Bye, guys.
Yes, so guys, watch all the sessions 5 to 10 times, absorb the information, digest the information, and apply the information, do all the assignments, and subscribe to our channel, and also press the bell icon, guys, and so that you will get a notification whenever we are uploading a session and you are always updated. Be persistent, consistent, and continuously keep learning, and go and watch all the sessions 5 to 10 times. Reinforcement learning will happen. You will absorb and digest, and when we go for application, so it will help you deeply, and you become world's best data scientists, AI engineers, AI researchers, AI scientists. So understand these terminologies, concepts, applications properly, tools, everything, so that you will become world's best top 1%, and become lifelong learner. Always learn deeply, so that it will help you. Thank you so much.
Yeah, bye, guys.